Hello, hello, and welcome back. In this video, we're going to work through an example of graphing this curve, r of t equal 4 cosine t I plus sine t j plus t over 2 pi k. Notice we could also represent this in component form for cosine t. I like to jump between the two forms because, well, different fields use different forms, and so I want you to be familiar with as many of these forms as we can. So 4 cosine t, sine t, t over 2 pi. So there's my x of t, is this one. Here's my y of t, and here's my z of t. So I'd like to figure out what this thing looks like. Now I could just start plugging in t values and graphing these vectors that come out, right? I could do that here. But there's sort of a better way to go about imagining this thing. So I'll show you that kind of analysis here. The idea is I want to be able to recognize curves or surfaces that I'm already familiar with and try and put this vector in those contexts. So what I notice here between the x and the y components is I have a cosine in the x and a sine in a y. So if I square x and I square y and add them together, I'm going to get something that resembles a circle or an ellipse. Right? I know cosine squared plus sine squared is going to give me 1, and I'll be able to recognize that. So what I'm going to do to make that happen is I'm going to divide the x component by 4, square it, and add it to the y component. Right? That's going to give me cosine squared plus sine squared. So let's just take a look at that. X of t squared, and I want to actually divide that by 4, plus... Actually, I want to divide it by 4 first before I square it, right? I got to get that 4 out of there first. So I'll do x of t over 4 squared plus y of t squared, and let's just see what we get. So x of t over 4, that's cosine t, so that's cosine squared of t, plus y of t squared is just sine squared of t, and I know that that's identically 1. So what this tells me then, if I expand this out, so this is x squared over 16 plus y squared is equal to 1. And we should be able to recognize this now as an ellipse centered at the origin. Right, so if I'm just graphing x and y here, just in 2 dimensions, so sort of just looking at the shadow. So what I want to do here is look at shadow, just shadow on x, y. I don't want on the xy plane. So I get that shadow by forcing my z component of my vector valued function to be 0. So if I just force this to be 0, I'm just looking at what my vector would look like if it were just on the xy plane. In some sense, that gives me the shadow of it, and I just get this curve here. I just get my ellipse centered at the origin. So if this is my x and this is my y, I know this is going to be in the x direction 4 and negative 4. So I'll put 4 here, negative 4 here, and the y I'm going to go from 1 to negative 1. If you're unfamiliar with how I'm getting those and how I'm graphing this ellipse, go back to chapter 12 or watch those introductory videos to section 13.6. And so the shadow on the xy plane, and notice cosine squared plus sine squared, my cosine is with the x, sine is with the y, so that means I'm tracing it out in this direction. I'm going to get this curve, and it's just going to keep repeating itself, and it has this orientation to it, so another positive orientation to it. And it'll just keep spinning around like this. So that's just if I look at the shadow. I'm spinning around on this ellipse. And if we want to think about it more, what this really is in 3 dimensions, so if I think of this not just in the xy plane, but in 3D, what is this figure? Well, it's missing a z variable, right? So that means it's a kind of cylinder. And in particular, now that we've recognized this, it is an elliptic cylinder centered at the origin. So this is an elliptic cylinder. Right, so imagine this now, xy plane, extrude it along the z-axis both positively and negatively. What this is saying is that my curve, since it satisfies this equation, my curve lies on this elliptic cylinder. So our curve is on this cylinder. So it's not the whole cylinder, but it is constrained to the elliptic cylinder. And now I can investigate my z component. So notice my z component is just t over 2 pi. So this is increasing linearly with t, and it's, scaled a bit by my parameter, t over 2 pi. So as t increases, my z value increases. As t increases, z increases. And this is a linear relationship, linearly. And the reverse of that is true as well. As t decreases, z decreases linearly. So what we're going to get, so it's traveling along the cylinder. As t increases, I'm going to move upward along the cylinder in the z direction. As t decreases, I'm going to move downward along the cylinder, circling it in that way. So let's go ahead and actually draw this thing. So here's y, here's z, and here's my x. So first thing I'm going to do is keep in mind that it's going to be working on that ellipse. So I'm going to go ahead and mark off 1, 2, 3, 4, 1, 2, 3, 4. And then we'll do 1 here for y, 1 and 1. And let's see, what do I want my t values to be? Oh yeah, it's not quite this. This is x squared over 16 equals 1. And what do I want my t values to be? I'm going to go back and reread the problem. Where do we want? We want to graph this curve where my t value is between 0 and 2 pi, and then again when it's between negative infinity and infinity. So I want to consider this curve for those two separate domains. So I'm going to focus on part A here. T is between 0 and 2 pi. So when t is 0, I'm going to be at this point on the ellipse, right? So here's my ellipse here, moving around. I'm going to do this a dotted line, just so I can keep this ellipse in mind. Oops. Keep this ellipse in mind as I draw this. And then remember, this is going to be, we're going to have an ellipse down here, we're going to have a cylinder, right? So it's going to move along this. And right, so if t is 0, I'm starting here, and then I'm going to move in this direction along the curve. When t is 0, my z component is also 0. So that means I'm going to start out here, and that's in the xy plane. And then as I move, as I increase t, I'm going to be moving in this direction around the ellipse, but my z value is going to be increasing. So I'm not just moving on the ellipse, I'm also moving off of the xy plane a bit. So I'm going to get this sort of shape. It's going to come back around. I'm still moving up in the t. It's kind of hard to draw in 3 dimensions. It's okay. I'm trying to get the main sort of points of that in. And so now I'm going to end up here at t equal 2 pi. My z value should be 1. So right here is a z value of 1. And so I just get this part of this spiral shape, what is a helix. And so I move not just on the ellipse, but also up a little bit as well. So by the time I trace out the full ellipse, I've also moved my z value up to 1. And so that is just, if I just plot that part, from here to there, that's my t between 0 and 2 pi. Now if I consider this going off to infinity, maybe I'll use green for this, not only will we get this part of the curve that we just drew, but it's also going to keep going. My t value is going to keep increasing, and I'm going to keep spiraling upwards like this. It's not meant to get smaller like that, sorry. But it's going to keep spiraling upwards, and my t can go in the negative direction. So that's going to send me this way around the ellipse, and I'm going to be getting more negative z values. So this is also now moving downward, so we're going to get a spiral like that. So the t, and that'll keep going. And it's important to remember what's the orientation of these things. So for the 0 to 2 pi, the orientation is actually the same as the other one, but I just want to put some arrows on here to tell me which way I'm headed, which way the particle on this thing is headed. And we get a spiral type shape. So I'm going to, because my drawing isn't isn't exceptional, I am going to jump to an interactive figure just so we can see this now graphed. So there is a few turns of this spiral, of this helix. And we're looking at the same thing that we just worked on, now graphed in this interactive figure. So again, as I increase t, this is what I was showing you. As it'll draw it out. We're always on this ellipse. Rather, the shadow is always on this ellipse, but we're moving upward along the elliptic cylinder. So this is graphed between 0 and 4 pi. Right, and here's that idea of the shadow again. If I sort of look at this curve from directly above as best I can, I get that ellipse. If I look at that here, it looks something like that. Right, and then maybe, yeah, the last thing is showing negative values of t. So here I'll jump down to t equals 0, and then I'll decrease it. Right, as I decrease, I'm moving in the other direction, opposite the direction of motion, because I'm decreasing t, and I'm heading downward, and again, staying on the this elliptical cylinder. All right, that's the idea. A lot of this is going to come down to recognizing familiar curves in 2 dimensions, which is why I wanted to spend so much time on that in the last chapter. So we're definitely going to see more of that. If you didn't heed my warnings then, review chapter 12. That's my advice, and I think you'll get this a lot better if you have a solid understanding of that. All right, I'll see you in the next video. We'll work another example. It's a fun one.